This is Ali Jawad and welcome to my YouTube channel. In this video, we will learn about lesson number 5 on chapter number 17, Magnetism, on Physics O-Level 5054 series. Those viewers who are watching this video for the first time, they are requested to go for lesson number 1 to 4. I am providing the link over here in the video. In our last lesson, we have started with the topic of temporary magnetism and its uses. So this lesson is actually in the continuation of the same topic. One of the important use of temporary magnetism is in electric bell. The figure shown on the screen is a circuit of electric bell. As you can observe, here we have a switch. When the switch is being pressed, the circuit gets complete and the electric current starts to flow through it. So when electric current passes through these coils, this generates magnetism. As we have discussed the magnetism in a solenoid in our lesson number 3. So you can revisit that video to just have a recap. When the current passes through the coil, this U-shaped iron bar becomes a magnet. Since iron is a soft magnetic material, so it gains temporary magnetism. It can be magnetized and demagnetized easily. So when this iron becomes a magnet, this iron armature connected with the hammer strikes the gong to produce a sound. And when the circuit gets open again, so this armature returns back to its position because of this pivot. When the current stops to flow, this iron piece loses its magnetism and the hammer returns to its original position because of the help of this pivot. Watch this again in the working condition. So this is how temporary magnetism is utilized in electric bell. There are other uses of temporary magnetism. For example, circuit breakers. As you can see over here in the diagram, this is a model of a normal circuit breaker which we use at our homes. So this is the live wire. The live wire means it carries the current from the source to the appliance. As you can see that the current is passing in the live wire and it also passes through solenoid and then reaches at this point. It is a point of connection with these brushes like structure. The brushes have a gap in between which is filled with this iron rod, and this completes the circuit. So the current enters the circuit breaker from the live wire. After passing through the solenoid, it reaches at this metallic end and it is connected to the neutral wire with the help of this iron rod and brushes. But what happens when heavy amount of current is passed in it? When heavy current passes through it, the solenoid receives a lot of current. And according to the right hand rule, as we have discussed in lesson number 3, the curl of the finger gives the direction of current while the thumb gives the direction of the north pole of the magnet. So when the current passes through solenoid, it becomes a magnet. When it becomes a magnet, the north pole and the south pole are generated, and the soft iron latch which was pressing the spring is attracted towards this magnet. This only happens when high amount of current passes through solenoid, because high amount of current generates high force of magnetism. So when the iron latch is attracted, this happens. As you can see in the figure number 2, the iron latch, which was actually pressing this 50 bar spring, has come down and has released this. Due to the deformation of the spring, the iron rods get opened and the terminals get disconnected. So now the live wire terminal is not connected with the neutral. But as soon as the current returns to its normal condition, the solenoid will again lose its magnetic properties, as it was working as a temporary magnet. And one can press this piston to return the circuit breaker to its original position. And again, the connection becomes complete and the current from live wire can go to the neutral to run the appliance. This is another example of temporary magnetism. The uses of hard disks are very common in laptops and computer devices. So what happens in these hard disks? As you can see, there is a magnetic head which is moving here and there on the rotating disk. These rotating disks are made up of soft magnetic material. They magnetize to store data and get demagnetized when we delete data from the hard disk. So let us see how does this magnetic head and disk works together to store data. If you may look at the two-dimensional diagram of this is the read and write head, which magnetizes or demagnetizes. And this rectangular bar is actually showing a layer of the rotating disk. So when read and write head moves, it passes the electric current to this rotating disk. And because of this current, there are magnetic regions which are specified by domains. To see what domains are, please go to lesson number 1. The magnetic regions are shown in the form of domains. However, as read and write head works and it passes the current, because of its current, the direction of domains gets changed. As we know that computer stores data in the form of binary numbers, that is 0 and 1. So the opposite domains are representing 1, while the domains in the rightward direction are representing 0. So when we have the opposite direction domain and another region of opposite direction domain, so there is a strong magnetic field generated in this region. As you can see, this is representing the no reverse region and reverse region. So this is how temporary magnetism works. But when we delete data, this read and write head again causes these domains to flip their direction and the magnetic field gets loses. So this is another example of temporary magnetism which can be used to store data in hard disks and other types of these devices such as floppy, which has been obsolete by now. Another important application of temporary magnetism is magnetic screening. In this application, we do not want the magnetic field to pass through a particular region. This is specifically used in CT scan rooms and MRI scan rooms at hospitals. So what we do, let us suppose that if we do not want magnetic field to interact with this area, So around this area, we will place a magnetic material. So what happens when the lines of magnet travel from north to south? Rather than passing straight through the air, they like to pass through magnetic materials. And when they like to pass through magnetic materials, they bend and try to pass through iron ring in this case, leaving the area in circular path empty, and they will not pass from here. This can be used for magnetic screening of certain devices where magnetic lines of forces are not very good for us. So in today's video, we have discussed several uses of temporary magnetism. I hope that you have enjoyed the lesson. Don't forget to subscribe our channel for the latest videos on Physics 5054. Thank you for watching it.